Okay, this is the question in the quiz with 4 options, and the question asked by the student is, how do we even begin to think about this problem? So here let us just think of the problem here. First of all, I want to highlight this word must. Yeah, must. Must and may are two different things. Will and could are two different things. Must and will implies certainty. May and could imply a possibility. So here this is a question of distinguishing between certainty and possibility. And on questions that revolve around this distinction between certainty and possibility, finally we have to think about the restrictions in the definitions of the functions. Now here we have, in all 5 cases, we have a logarithm of a logarithm. Now either the argument is changing as in a and d, yeah, or the base is changing as in b and c. And so now we have to think which of these cases provides the certainty of non-definition or non-existence. So here we need to ask ourselves what restrictions on the value of x are placed by the logarithmic function. Now by definition, for real valued functions, for log x to the base a to exist, x must be positive. In other words, log to the base a of log to the base b of x will not exist on 2 conditions. First, either if x itself is less than or equal to 0, for in that case log x to the base b will not exist, that is the innermost function. Or the second case, if log x to the base b is less than or equal to 0, in which case log to the base a of log to the base b of x, the whole thing will not exist. Yeah, that is the outermost function will not exist. Now since the question deals with certainty, yeah, indicated by the use of must, we need to ignore those options in which non-existence is only a possibility and hone in on the option in which non-existence is a certainty. We are given that log to the base m of log to the base m x is defined. What this means is that both the innermost and outermost functions are defined. For the innermost function to be defined, x must be positive. For the outermost function to be defined, log x to the base m must be positive. Now the options again are: a is log to the base m of log to the base m x minus 1. B is log to the base 1 by m of log to the base m of x. C is log to the base m of log to the base 1 by m of x. And D is log to the base m of 1 minus log to the base m of x. Now it is evident that the arguments of the outermost logarithm, that is here, the arguments of log to the base mx minus 1, log to the base mx, log to the base 1 by mx, and 1 minus log to the base mx, those are all defined simply because log x to the base m is defined. Yeah, if log x to the base m is defined, then even log x to the base 1 by m will be defined. Okay, and so the issue now revolves around the simple question: in which of these options do we certainly get an argument that is negative?